I am going to talk to you about reactive JavaScript, as so stated, with RxJS. So a little bit about me. My name is Maida. I work for an identity and access management company called Auth0, where I manage the content and community teams. I am a Google developer expert in web technologies and Angular, and I also run an Angular meetup in Ann Arbor, Michigan. So what is reactive programming? Well, according to Wikipedia, it's a declarative programming paradigm concerned with the data streams and the propagation of change, which is great. But in slightly simpler terms, it's about observing and reacting to data streams over time. I'm going to start by talking about this in sort of a metaphorical way so that we can think about the concept, the larger concept at work here. So let's say that you run a publishing service that does periodicals. Every month you do a publishing run, programming books, which everybody loves, I know. People can subscribe to your service to get books on a specific topic every month, and they pick the topic that they're choosing, and then you send the books to the subscribers when you do your publishing run. So some time goes by, and you get somebody who signs up for your service. And every month, this particular person, maybe they're a JavaScript developer, and they want to get your book about JavaScript every time you do your run. Now, some more time goes by, and let's say you get another subscriber. This person's interested in something else. When your publishing run happens, your JavaScript subscriber is going to continue to get your JavaScript book, the publication that you do each month on JavaScript. And then this new subscriber, however, maybe they want books specifically on reactive programming, and they want you to do something special with their books. So they want maybe a bookmark set in the table of contents or something every month, every time they get their book. So more time goes by, another month goes by, and these subscribers continue to get the specific things that they've signed up for. Now, if we take this example into sort of reactive programming land, your source observable is going to be the publication run that you do where you publish all of the books, right, each month. And then we have observables that are derived from the source. So these can be subscribed to by people, and they also may be transformed from the source. So we've filtered both of these, right? We don't send the JavaScript subscriber the entire publishing run with every single book. We send them the JavaScript book. Same goes for the reactive programming subscriber, but we've also mapped their value because we've done a transformation where we add a bookmark and we put it in a specific place. Now, subscribers in this example are called the same thing they are in programming. So these are entities that subscribe to the observables, and then they can do something as a reaction to the values they receive over time. So for example, when somebody receives their book, they could put it on a bookshelf, they could take it to a book club, they could give it to someone else, whatever they want. Now, in reactive programming, there's this concept of everything is a stream. And a lot of times people represent this with the yoga dog, which is it's this sort of high-minded thing. But what about a practical example that could apply to us? We're developers. So how about something like authentication? Authentication is a series of events that occur over time. So just as an example, let's say you create a stream of authentication events. The first thing that's going to happen, most likely, is a user is going to enter their credentials into a login form, and then they're going to click a login button. And when that happens, in our stream, what we can do is we can emit an event, and so we can say maybe this is an init login event. We emit this from our data stream, and then in our application, we can subscribe to this stream so that we know when these things happen, and then we can react to them in some way. Now maybe after successful authentication, what we expect is the application will receive something back, maybe some user information in the form of a JSON object with like a name and a picture or something like that, as well as maybe an access token, which is going to allow us to call our application secure API endpoints. Now our subscriber, because we are watching the stream for things to happen and to react to the events, we can do something as soon as we get that information back from our stream. So when we know that we have user information, we could do something like display a profile page, we can greet the user by name, and then we could also do something like fire off an API call to a secure endpoint because we know we have that token available at this time. Now the last thing that users generally do is log out. So when they do log out and we receive notification that this event has happened, then we could do something like clear out authentication data from our application memory. We can delete the local user info object. We can delete the access token so that we're all set as far as logout being cleaned up on the application level. And that's great, right? It sounds nice. But how do we actually apply this in applications? Well, in JavaScript, there's a library called RxJS. This is a reactive programming library for JavaScript. So this is the GitHub, and this is part of an org called Reactive Extensions. And I want you to know that RxJS is the library specifically designed for JavaScript, but there are libraries for many different programming languages. So everything that I'm going to talk about today, the examples in code are going to be in JavaScript. You can apply these concepts across languages, back-end, front-end, etc. There's an RxJava library, there is Rx.net, there's RxScala, etc. RxJS in particular is reasonably popular, and this is in part due to the fact that the Angular framework is built with RxJS, and so Angular developers who are working with this framework essentially need to learn RxJS. But the important thing to know is RxJS can be used in any JavaScript application. It's not Angular specific. You can make your React apps more reactive by using RxJS. You can add it to Vue, you can put it in vanilla JavaScript applications, etc., so on and so forth. So if we come back to this idea of everything being a stream, it's not really that everything already is a stream, right? It's more that everything can be a stream. We saw the authentication status example, but this is something we need to put together, right? And we can accomplish this using RxJS, right? But what do we do? How do we actually do that? And I think the easiest way to start thinking reactively, if you're not used to a reactive paradigm, is by taking existing data and turning them into observables. And the Rx libraries do a great job of this by offering you this observable creation method called from, and then from also has several variants of itself. Now, the purpose of from is to convert various other objects and data types into observables. If we look at the actual docs for this, this is what they look like. And there's a bunch of things to unpack here. We saw a lot of colorful things and examples. So these things are called marble diagrams. They're visual representations of observables. So it's a visual representation of data over time. On your x-axis here, you have your time progressing, and then the colorful marbles, so to speak, are events being emitted over time, right? And then we saw a lot of examples in the docs that look something like this. Now, if you look at this, you can sort of see that we create an observable from a series of arguments, and those arguments in this example happen to be 1, 2, 3, and then when you subscribe to them, they emit these values, 1, 2, 3, and then it's done. And I mean, I don't know about you guys, but when I saw this, this is very abstract to me. I didn't get it. It didn't sink in. So going from the docs and the examples that look like this, where in my applications, I'm not multiplying arrays of numbers together. Like that's not what I do as an app developer. So how about a more practical example with code? So this is an application that I built. It's actually a really simple application. What it does is it uses NASA's API for astronomy picture of the day. And so every day, if you call this API, you'll get just a JSON object back that has some data in it. It's got a URL to a high definition image of something beautiful and astronomy related, and then you'll get some information like a title, some description, and information about the photographer. Now, if you look, I know it's kind of hard to see, but if you look in the upper left-hand corner here, I've added a button with a star in it that if you click the button, it'll just increment a counter. And if you hold the mouse down on the button, it'll continually increment this number. And if you mouse off or if you let go of the mouse button, then it'll stop incrementing. Now, if you're familiar with the way clapping works on Medium, it's basically the same thing. It's just an indication that I can put into the app that says this is how much I like this picture. So pretty straightforward. Now, if we take a look at the code to implement this, I used RxJS to do this. And I want to start by talking about how I converted these event streams, right? So what I'm doing here is I'm creating a click observable, and the $ at the end of the constant name is essentially a common notation used for Reactive that just indicates that this is going to be an observable string. This is something we're going to be able to subscribe to. Now, this stream is just going to emit a value every time this star button is clicked. So it's using the DOM event of clicking on this particular element to emit a value from the stream, so it's data points over time. Now, in order to react to this, though, I need to subscribe to it, right? So I'm going to subscribe to my click observable, and then whenever that observable emits a value, so I know that a click event occurred, I'm going to run this function called add star, which is pretty self-explanatory, I think. But now the other thing that I want to do besides clicking is I want to have that functionality where if I hold the mouse down on the button, it's going to incrementally add stars and then stop if I do some other specific thing like mouse off or let go of the mouse button. And in order to do that, because we don't have sort of a native DOM event that specifically is that, I'm going to create that by using these 3 other DOM events, which are mouse down, mouse up, and mouse leave on my star button specifically. So in order to take these 3 other streams and implement something like what I would call a hold functionality, I'm going to create a hold stream. And I'm going to start with the mouse down event stream. And what I'm going to do with that is I'm actually going to run an operator called switch map. And what switch map does is it says when a new inner observable is emitted, when a value comes from the inner observable, the switch map is going to stop emitting from the previous observable, and it's going to start emitting from the new one. So basically it's saying on every new mouse down, stop paying attention to the last one, and start paying attention to this new one. So start over and don't let things sort of stack up and get really messy. Now I'm also going to use interval, and this is an observable creation method which says I want to do something, I want to emit something at some specific interval. I'm saying I want it to do it every 200 milliseconds because I don't want to just hold the mouse button down and have this sort of just go nuts, like really, really fast. I want it to be a little more deliberate than that. So now I have my interval that emits values, that starts emitting values after I have that mouse down event, and I want it to do this until something else happens. So I can use take until to say emit values until the observable I'm including now happens, something gets emitted from it. And because I want it to stop if the user either mouses up, lets go of the mouse button, or if they drag the mouse off of the button, the add star button, then I'm going to merge these 2 observables together so that I can take until either of these things happens. So if we come back to the whole thing, in summary basically, when a mouse down event is emitted on this star button initially, every 200 milliseconds, a value is going to be emitted from my hold stream until the user either lets go of the mouse button or mouses off of that star button. And then the last thing I need to do, of course, is subscribe to it so that I can react to these values that are being emitted. So I'm going to again run my add star method whenever there's an emission. And that's great, right? So we actually were able to implement some pretty cool observable streams based on user interface events. And RxJS is great for this. There's a lot of sort of out-of-the-box stuff for it. But RxJS is really powerful way beyond things like DOM events. And the DOM event example was very JavaScript specific. But the rest of what I'm going to talk about is applicable in back-end applications as well. So what else can we do with something like reactive programming and these Rx libraries? Well, we can actually implement state management. And one of the things that makes state management really nice in Rx is something called subjects. Now, subjects are observables, but they have state. So that means that they keep a list of observers. They also implement what's called the observer interface, which means they have methods called next, error, and complete, and you can run these methods on them manually. So in our example with the DOM events, you're not running next to tell it when there was a click. It's the DOM having a click event occur, and then we're just sort of paying attention to it, right? But with subjects, we can actually create an observable stream, and we can tell it to emit an event, when to emit the event, and what is going to be in it. Now, the last thing that some types of subjects can do is something called multicasting, and this is when one observable execution is shared amongst multiple subscribers. So if you think about the concept of state management, this is something that's really useful for doing something like creating a global store. The thing that happens, though, is when you give people sort of free and unfettered access throughout an application across a team to something as powerful as the next method, which pushes things into a global store, then you can induce what I like to call sort of a reactive power trip, where people are just run next wherever I need to, touch any kind of data in the app. I'm just going to run next, and it's going to be magical, and nothing's going to break ever. So when it comes to using something like reactive extensions or RxJS with something like state management, it's very important that with great power comes great responsibility. You have to have some kind of strategy to do this, especially if you're working in a larger team or with a larger application. So I'm going to tell you a little bit about a couple of different strategies that you can do for this. And the first thing is behavior subjects. So I can use a behavior subject to create a store subject. This is essentially going to be the holder for my global state. Now, behavior subjects are a specific type of subject, and they can do specific things. So the first thing about behavior subjects is they require an initial value on instantiation. They also store the current value. And finally, they notify subscribers on subscription of the value that's in the subject. So, for example, if I have my store subject and I have not emitted anything from it yet, I haven't done an update in my application to change the state, if I get a subscriber in my application, when they subscribe, they're going to receive the value which is the initial state, the one that I gave it on instantiation. If I have run the next method a few times and updated the state and I get another subscriber, they're going to receive whatever the latest emitted value was. So in this way, all of my subscribers are synchronized to the same value, the same current state. Now, the other thing I want to do here, though, is I want to create a public store observable. Because like I said, the next method is very powerful. It's not something that we necessarily want everywhere in our application to be able to do that. So running something like store subject, we want our store subject preferably to be private, and then we have a public store observable. And in order to create this, we just take the private store subject and we can use the asObservable method on it. And what this does is it hides the identity of the source sequence. So if I were to go out into my application and try to do state.store $.next, nothing, it wouldn't actually work. Right? So I have a public way to subscribe to my store. Now, in the earlier example, you saw I piped in a bunch of transformations to do different things to my observable before I emit the values. If we use pipe to add operators, then this also serves to hide the identity of the source sequence. So you don't need to do asObservable.pipe if you're going to be using operators. So what we've done here really, or what we want to be able to do with this, is prevent leaky abstractions. We want to have a defined strategy for how our application should interact with the store. We want to be able to share that strategy with other developers coming onto our team. We want to be able to have it be readable and understandable when people join the team or start working on our application. So if we come back to the example with the little adding stars to say how much I like it. Let's add state to this one. What I'm going to do first is I'm going to start by creating a state service class. And as a little bonus here, I'm going to use TypeScript because I love TypeScript and it makes things a lot easier to understand, especially if you're familiar with JavaScript's very loose typing and type coercion and things like that. So my state class is going to have something in it that looks something like this. And what I'm doing here is I'm creating a public apod store. I'm going to say apod because it's a lot easier than saying astronomy picture of the day. From a private apod subject. And then I'm going to use an operator called scan. And scan is very useful for state management because it gives you access to a few specific things. The first thing that you're going to be able to get when you run scan is the accumulated value. So this is essentially the current state, the latest state, whatever state the apod subject is currently holding. And like to be clear, this is what's going to run when I do try to run the next method on this. When I run the next method on my apod subject, it's going to pass through all of this. I expect the current value, the accumulated value, to have a specific shape. So this is a TypeScript interface. I expect it to be an interface that looks like an apod, the data that would be in my astronomy picture of the day. It might have stars, or it might not yet, because I may have just gotten the data from the API and not added any stars, and in that case it wouldn't have stars at this point. But I'm going to have my HG URL, my title, etc., all of that stuff that NASA gives me when I call it the API. The next thing that I have access to, clear more obviously, is the new value, and this is the value that I am sending in to my apod subject using the next method. So this is my update. Now, this could be the initial API data because I might have just called the NASA API and it's directly what I'm getting back from that API. Or it could just be an update, the shape of this update interface, which is just an object with stars and some value for stars. Now what I'm going to do to actually return my state is I'm going to return a new object that is the accumulated value with updates from the new value. And I'm going to return this as a new object so that it's immutable, because I don't want to be mutating anything that I've had previously. The shape of that is going to be, again, it's going to look like my apod interface. It's going to have my data from the NASA API, and then it's going to have some value for stars. Finally, this last thing is an initial state. So what the purpose of this is in a scan function is if there is no initial value that's provided here, then this entire function is going to be skipped the first time we run the next method. So that means the first value that is sent into the next method just automatically becomes the first state without passing through this function first. Now I talked about wanting to have some kind of a strategy, an organized strategy for this, and we're going to start doing that by first setting up a way to send values into our store because the apod subject is private, right? So we can't just run the apod subject.next from anywhere in the application. So I'm going to set up a public method called setStore, and I can set expectations for what people send into this. I can say I want it to be shape of this apod, or I want it to be specifically this update object that has stars and a number. And then I'm going to be able to emit that value from my apod subject by running the next method. And that's actually all there is to our state class in this case. It's a very simple application. But the next thing that we need to do is have some service that manages the data. It's going to get the data from the API, and it's also going to interact with the state class itself. So here we're going to grab the data. I'm really just going to use from fetch, because again, this is another from method that is provided by Rx. It's a wrapper around fetch. So it can make an API call, and then the result that you're going to get back is actually an observable in this case. So I'm going to request my apod data from the NASA API, and then if everything is fine, if we get a good response, we're going to go ahead and run that setStore method from our state class. So we're going to set the apod data in the store that we received from the API. Now the data service also wants to set expectations as well, and what we're going to do is we're going to create an add stars method. And because the only way besides getting the data from the API that we're actually making updates to our store in this particular application is by adding stars, we're going to be able to say explicitly, here's the method to run when you add stars. Here I'm expecting you to send me a stars object that is specifically that object with stars and a number. And then I'm going to run my state class of set store, and I'm going to send that stars object into the store. So if we come back to our main view, the main component in this ecosystem, the first thing that we need to do is we need to get that data from the API. So we have our apod data stream that we have set up, but in order to actually initialize the call to the API, we have to subscribe. So subscribing initiates that call, and then once we get data back, when a value has been emitted from that stream, that apod data stream that we use to get the data, then we can run our setup stars function, which, as you recall, looked like this. We went over this earlier. But I want to pay more attention to this particular section of it now. And this is where we're saying, basically, here's the new value is going to be stars and some number. And then when we add a star, we're just going to increment that number. But now, what we want to do is we actually want to run the add stars method from our data service to send that new value to the store and not just keep it local. So here is the method to do that. And that's actually all we need to do to implement some pretty simple state management. Right? This is a fairly basic example. There's not a whole lot going on here, but you can see how this could scale up a lot more efficiently now if we wanted to expand this into something more robust. But what about something that's a little more complicated, like out of the gate? Well, how about optimistic updates? So optimistic updates is when you update a UI with the optimistic assumption that your API calls are going to succeed. So you're going to update the UI first, assuming you're going to get a successful API call, and then you're going to make the API call silently, sort of in the background. And then you'll react if there's an error, but if there is no error, then everything was fine. We already did the optimism part. This is something that can make applications look really fast, and you've probably seen it in the wild. For example, if you use Trello, Trello does this. It's not something you want to do for high-stakes operations, clearly. If you are changing users' password or doing financial transactions for a banking app or something, this is probably a terrible idea. But if you have an API that succeeds most of the time and it's pretty low stakes transactions, then this can be something that's really good for user experience. So I built another application to demonstrate this, and this one actually uses the near-Earth objects from NASA. This is an API that basically just gives us back a list of all of the asteroids that are close to Earth for some period of time. So what I'm going to do here is I'm going to call that API, and then I'm going to just display a list of everything that I get back. And I can also have a few other different views of this. So I have my global store that has everything, and then I have a list of small ones and a list of bigger, faster ones. So if we go ahead and open the inspector here, I'm going to open the console, and then as you can see, I've added a functionality to add nicknames to these items. I'm going to call this one Armageddon because it's actually flagged by NASA as potentially hazardous. I have an immediate update in my UI, and then if you saw like a second or two later, I got a response from the API. It was successful, so I just logged out the response that said, hey, this worked. Now, if I go into my other views, I can see that my change has persisted across the global state, and so all of my views have it. Now let's do another one. This one is really, really small, so I'm going to call it tiny. I'm going to say save. Got immediate update in the UI. But then there was a problem on the API. It wasn't successful in saving this update. So I can log that out to the console, and then I can also do something in my UI. I said, hey, there was an issue with this. If I come back to my main view and find that same item again, then it doesn't have the name anymore because I had updated it optimistically in the store, and then I rolled that back when the API call failed. So this is essentially what optimistic updates looks like. Now, to implement this with something like RxJS, it's actually fairly straightforward. I'm going to create a state class, and again, I want to keep all my state management logic organized in one place. So I'm keeping the state separate from something like going and getting the data, like with the previous example. Now, I'm going to create a private, again, the abbreviations, because near Earth object is too long to write out all the time and to say. So I'm going to create a private NeoStore subject, and then I'm going to create my public NeoStore observable. This time I'm going to use as observable because I'm not going to transform this value. But I also need something else now. I need a way to track errors, because you would never put errors in your store. That's something that we just don't do. So I want to create an error subject. I'm using a subject instead of a behavior subject this time, because with a subject, I don't actually need multicasting functionality, and I don't need a default first value. I'm going to create my private subject. I'm going to create my public store, or my public errors observable. Excuse me. And then I need a way to track the previous state, because if I optimistically update my UI and then something goes wrong with the API, then I need to know what it was before so I can roll it back. So the way to do this is I can just create a local member called previous state, and I can get the value of my NeoStore subject at any given time. So this is, I'm going to grab it when I run this function. Then I need a way to dismiss errors out, because again, my store doesn't really talk to the errors subject. They're not interconnected in a way that the error subject would automatically be cleared if something succeeded in the store. So in order to dismiss errors, I'm just going to emit a null value from my error subject. The next thing I need is a way to set my store. So in order to set the store, I expect to be passed an array of neo objects, or near Earth objects. And the things that I'm going to do here, the first thing I'm going to do is I'm going to set the previous state. Because before I change the state, I need to know what it is currently. Then I'm going to emit the array as the next state. So this is the array that was passed in. It's what we get from the API, or what it is after something happens. And then I'm going to clear errors in case there were any previously, and now we've updated the state, so I'm going to make sure that anything that was there previously is gone. I also need a way to update the specific near-Earth objects, for example, when I add the nickname. This is what's going to run. So in this case, I'm going to set the previous state, and then I'm going to create a new state by mapping the previous state. And I'm going to go and look for the same object in that array that matches the object I'm trying to change. And then I'm going to return a new object in its place with the target near Earth object updated with the new nickname information that I've added. So again, we're talking about immutability here. This is going to be immutable. After I've done that, then I'm going to emit the new state from my NeoStore subject. And once more, I'm going to clear the errors. Now my state error function is important too, because I need a way to actually handle the errors that occur. So it's going to accept an error message. In this case, I just want it to be a string, because I can grab it from an error response from the API, for example. I'm going to emit that string from my error subject, and then I'm going to emit the previous state from my store subject, because I want to roll it back if something bad happened. So that's all that's in my state class. And now I have, like in the previous example, a data service that is going to manage all the data side. And we're probably exhausted by code now, so I'm just going to describe these more visually. The first thing I'm going to need to do is fetch the API data and then set the store. I did this in the first example too, so it's nothing super new. Now I have my API data available in my application. And then I'm going to create an update method that is going to update the store using that update neo method that I had in my state class. Right? And this is the method that's going to run when I add nicknames. This is going to update the local store, and therefore the UI. This is the optimistic part, the local optimistic part. But then the reason why update is an observable in the first place is because it's going to make an API call also. So it's going to update locally, then it's going to send the data to the API. If everything is good, then I can do something like just log a success message or something, or swallow this silently. So we see if there's success, then we have this nickname information in the API also, and then I'm done with that. So I don't need to do anything else if I have a successful API call, because I updated the state optimistically and locally first. But if something goes wrong with that API call, if there's an HTTP error, then I need to be able to handle that, so I'm going to handle it using the state error method that I set up earlier. By subscribing to this stream, I can do things like show an error message like a toast in the UI, and I can also emit the previous state, which looks like this. I can do some fancy stuff where I keep track of what the state was before locally in my component, so that I can keep that value in like the text field in case I want people to just sort of spam it over and over until the API works. But then that's really all there is. That's quite a bit more complex state management, but in not that much code. And I don't know how many people here have tried to do optimistic updates with like other state management libraries, or just sort of like organically with no assistance from any other libraries. It's not a super easy, fun thing to do if you don't have something sort of helping you out. So again, if we come back to the idea of doing more robust things, like state management, reactively, it's great, there's a lot of options, but it's important to have some kind of a strategy. It's equally important to know that with something like Rx, this is your strategy. You make your own choices. If you want to decouple your business logic, you can, or you can totally not do that. You can tie all your business logic to your state. You can have more abstraction. I showed you, there's some of the abstraction in the examples I showed you. Or you can not abstract anything. And that's totally up to you. There's different strategies and approaches to doing this. And I hope that in these 35 minutes, I've given you some ideas just to sort of start thinking about this. The slides and resources for this talk are available at this link. And I really appreciate you giving me some of your time today. So thank you very much.